So today we have a really challenging system of equation. What makes this equation challenging is just because of this x plus y the whole square in this LHS. If this was not there, this problem was really very easy. But as this is included, this problem got a real tough and challenging. And this video is going to be very lengthy because this problem is challenging. So as this much hard work is done from my side, you can just do a small work, and that is to just hit the subscribe button. It will take your no time only. So no problem, let us see this solution, and I think you will going to be like it, because even for this hard problem that method is very nice and short, and it's a very standard way, no kind of assumption is there. So let us do it. First of all, let under root 25 means, let it be clear, yes, under root 25 minus x square, let it be equals to a. So if this is equals to a, I get the value of x is equals to square root of 25 minus x, not x square, a square. So this is the value of single times x if under root 25 minus x square is equals to a square. Similarly, square root of 25 minus b square, yes, let it be equals to not b square, y square. Y square, let it be equals to b. So from here we get that value of y is equals to square root of 25 minus b square. So this both things are considered as a and b. So as we will find the value of a and b, we will substitute that over here to obtain the value of x and y. Yes, very simple thing. Now I can see 25 minus x square minus 25 minus y square is equals to square root of a. So instead of that, according to this values which we have let it, we have just let, yes. So from here we get that instead of that we can write a minus b. So let the color be changed, yes. So instead of that we can write a minus b is equals to square root of 8. And the second one, it's a plus b. You can observe over there, yes. A plus b, and that is equals to square root of 16 plus x plus y the whole square, yes. Now instead of this x plus y the whole square, that's why I found the value of x and y. So when we will open this over here, x plus y the whole square, so we will put the values according to that. Now what we will do is square this both the equations from LHS and RHS. So we will obtain this thing, a square plus b square minus 2 times ab is equals to 8. And for the second one we will obtain a square plus b square plus 2 times ab is 16 plus x plus y the whole square, yes, x plus y the whole square. Now in this both equations I will just add this both equations together. So adding this both equation together, so I can observe from the LHS part, negative 2 times ab, positive 2 times ab got cancelled out, and a square b square together form 2 times a square plus b square, yes. And that is equals to what, 8 plus 16, that is 24. And opening this over here, so it would be x square plus y square plus 2 times x times y, yes. Now remember the value of x square, sorry, the value of only single times x and single times y. So from here we can also have the value of x square. So we can have x square is 25 minus a square, and over here we get that y square is 25 minus b square, yes. So instead of x square and y square over here, I will put that value, that is nothing but 25 minus a square for the value of x square, and 25 minus b square for the value of y square, plus 2 times x and y. So x and y has a value of under root 25 minus a square and under root 25 minus b square, yes. And plus 24 over here, and that is equals to what, plus sign, and that is equals to 2 times a square plus b square. Now from here I can observe as normal simplifications things are there. 2 times a square plus b square is equals to 24 plus 25 plus 25 is equals to 50 minus a square minus b square, so minus a square minus b square plus of 2 times square root of 25 minus a square and multiply by 25 minus b square. Now from here I will just shift negative a square and negative b square at the LHS part. So when they will be shifted, so 2 times already is there, so they are going to add up and it will form 3 times. So let me write that. So 3 times a square plus b square is equals to 24 plus 50 plus 2 times square root of 25 minus a square and into 25 minus b square, yes. Till now nothing very complex has been there, all things are normal, nothing to be get afraid, yes. Now remember from here, a square plus b square minus 2ab is equals to 8. So from here I can obtain a square plus b square is equals to 8 plus 2 times ab. This shifted over here. So it's the value of a square plus b square. Now remember here it's 3 times a square plus b square. So I can put that value, and that value is 8 plus 2 times ab. So 3 into 8 plus 2 times ab. So let us just open the bracket over here. So 3 into 8 is 24, and 3 into 6 is, 3 into 2 is 6. So 24 plus 3 into 2, that is 6 times ab, and that is equals to 24 plus 50 plus 2 times square root of 25 minus a square, 25 minus b square. These both are in multiplication, yes. Now that's why I was not adding 24 and 50, because they both were going to cancel, yes. Now shifting 50 over here, so 6 times ab minus 50, and from this both I can take 2 common. So it will be like this way, 2 taken common, so 3 times ab minus 25, and that is equals to 2 times square root of, now just multiplying this both, as we know the exponential rule, square root of a square root of b is square root of ab. So similarly over here I will just take the common square root and multiply the brackets inside. So it would be like this way, 25 into 25, 625 minus 25b square minus 25a square and positive a square b square. Yes, it's a normal thing over here. Just we have multiplied this both brackets together and all of them inside the under root according to the exponential rule. Now I can see 2 and 2 got cancelled over here, and in the next step what I will do is square the both sides, so that this common square root in the arches will get excluded, and this I have to just square over here. So here it would form 9 times a square b square plus 25 square, that is 625 minus 2366 into 25, 150 ab, and that is equals to square of this whole thing, that is 625. This and this got cancelled. So 625 minus 25 b square minus 25 a square plus a square b square. Yes. Now 625 got cancelled out. 9 times a square plus b square is already there. So 9 times a square b square minus 150 ab. 150 is there. 150 ab. And that is equals to what? A square b square, which is over here. So it will shift over here. I've just shifted over here. So 9 times a square b square minus of a square b square will give me 8 a square b square. So write it over here. 8 times a square b square minus 150 ab, that is equals to negative 25 times a square plus b square. Both of them negative, so when I've taken negative 25 common, they become addition. Now remember from this step over here, where the step is gone, yes, a square plus b square is 8 plus 2ab. So I will just replace a square plus b square as 2ab. So let us do that. So 8 times a square b square minus 15 times 150 times ab is equals to negative 25 times 8 plus 2ab. Now opening the bracket over here, so 8 times a square b square minus 150 ab is equals to negative times 200 and negative 50 ab. Yes, so it will give me 8 times a square b square. This shifted not 5 times, it's 50 times ab. Yes, 50 times AB. Now 50 times AB shifted over here, so negative 150 AB, positive 50 AB will give me negative 100 times AB and positive 200, and that is equals to 0. Now from the table of 4 I can see 2 times a square b square, not table of 4, from the table of, yes, from the table of 4, 2 times a square b square minus 25 times AB and plus over here it would be 50, yes, 50, yes, 50 times 50, and that is equals to 0. Now let us factor it out, so I can observe it would be factored out this way. 2 times a square b square, it's 200, 2 into 50 is 100, and the answer we need is positive, so it would be negative 20 ab, negative 5 ab, and positive 50 is equals to 0. So from here I get that 2 times ab taken common, so ab minus 10, and from here negative 5 is taken common, so ab minus 10, and that is equals to 0. So from here we get that ab minus 10 or else 2 times ab minus 5 is equals to 0. So value of ab we obtained is either positive 10 or else 5 upon 2. Yes, either 10 or else 5 upon 2. This is the value of ab. And why they have got positive? Because it's because x and y, both of them were in under root. So the value of AB we obtained is going to be positive, so it's right. You can see it's got very lengthy to find the value of AB over here only. It got too small to be visible. No problem. AB we have got as 10 and 5 by 2. So writing it over here from now. It's like the interval. You have just crossed the interval. So let me write over here as a column because we have two different values of A and B. So let me make a nice column over here, a bigger one. Yes. Now here we will take that AB is equals to 10 and here we have that AB is equals to 5 by 2. Yes. Now we can take either of this equation. I will go with the first equation, that is A minus B equals to square root of 8. So A minus B is equals to square root of 8. Let it be clear. Yes. A minus B is equals to square root of 8 and AB is equals to 10. So from here I get that A is equals to under root A plus B. So in this product A into B, I will just replace A with this value. So I will get square root of 8 plus B into B is equals to 10. So B square plus square root of 8 is nothing but 2 times under root 2 times B, that is equals to 10. So this much thing has been done, that B square plus 2 times square root of 2 times B is equals to 10. So from here it would be like this way. Now I will use the completing the square method. So I will take it like this way. B the whole square plus 2 times square root of 2 times B plus square root of 2 times the whole square. So as I am adding it over here, so I have to, this thing external I added over here, so I have to add it to the RHS. So 10 plus square root of 2 the whole square means 2. So 10 plus 2 is equals to 12. Now I can observe over here is the identity A square plus 2 times AB plus B square. So it can be written as A plus B, that is B plus under root 2 the whole square, and that is equals to 12. Now I have to take the square root sign over there. So B plus square root of 2 is square root of 12. So I obtain B is equals to square root of 12 minus square root of 2. Yes, this is the value of B. Now from here I can get that A. So remember here is, yes, this was the nice equation. A is equals to square root of 8 plus B. And square root of 8 is nothing but 2 times square root of 2 plus the value of B, and value of B is square root of 12 minus square root of 2. So we get that A is equals to 12 as it is, and 2 times this minus this is square root of 2 plus square root of 12, and that is the value of A. So value of A and B has been found. Now we will put that in these equations, that are the value for X and Y. Yes, remember that X is equals to 25 minus A square and Y is equals to 25 minus B square. So let us do that over here quickly. So square root of 25 minus A square will give me the value of X. So I get that it's equals to under root 25 minus A square. So 2 plus 12 is 14. Yes, 2 plus 12 is 14, and minus 2 times square root of 2 into square root of 12. So X is equals to, over here it would be 11 minus, over here I can observe square root of 12 is nothing but it's like square root of 2 into 2, let it be clear, yes, 2 into 2 into 3. So it can be written as square root of 3 into 2. So square root of 3 into 2. So it would be 2 into 2, 4 times square root of 6. Yes, this is the value of X. Square root of 11 minus 4 under root 6. And as we will put the value of B in the second equation, that is for Y. So let's do that. So Y is equals to under root 25 minus B square. So value of B we have it square root of 12 minus 2. So it would be minus 24. And now plus the same thing, only the plus sign will come, and it would be 4 square root of 6. So value of Y we obtained is square root of 11 minus and minus, sorry, here it will be positive 4 under root 6, and that's the value of Y. X and Y has been obtained very nicely by keeping AB equals to 10. Now also we have the value of AB is equals to 5 by 2. So let's do that. So as we have done over here, A minus B equals to square root of 2 and A is equals to square root of A plus B. Similarly over here, A minus B is equals to square root of 2. A is equals to, not square root of 2, it's 2 times root 2, that's nothing but 8. 2 times under root 2. So we obtain A is equals to 2 times under root 2 plus B. So now I will keep, instead of this A, this value of A, so it would become 2 times under root 2 times plus B into B is equals to 5 upon 2. So from here, shifting this 2 over here also, or else keeping it there only. So from here I obtain B square plus 2 times square root of 2 times B. And as we have done over here, completing the square, we will do over here, I will just add square root of 2 the whole square over here and add it over there. So 5 plus 2 plus 2. 5 plus 2 plus 2. So from here I get b plus square root of 2 the whole square, and that is equals to 2 to 4 and 4 and 5 9 upon 2. Yes, the same method as we've done over here to factor out. And now over here taking the square over there, so b plus square root of 2 is square root of 9 upon 2, so it would be 3 upon square root of 2. So from here we get that value of b is equals to 3 upon square root of 2 minus square root of 2, so it would be square root of 2 into square root of 2 means positive 2, so 3 minus 2 is 1, and we get that b is equals to 1 upon square root of 2. So this is the value of b. So keeping it in that equation, that is this one. Yes, so getting the value of a. So a is equals to 2 times square root of 2 plus b, so plus 1 upon root 2. So from here we get that value of a is 2 into square root of 2 into square root of 2 means 4. 4 plus 1 5. So we get that a is equals to 5 upon square root of 2. So now let us put that in that original equation, means to get the value of x and y. So value of x is equals to square root of 25 minus a square. So a square is 25 upon 2. So we get that value of x is 5 upon under root 2, and it can be plus and minus because we are just breaking the square root, so it can be plus and minus under root 5. In that also the previous case, let me write over there x is equals to plus and minus under root 5 by 2. And similarly for the value of y we have to just think, yes, the value of y, and for value of y we have square root of 25 minus 1 upon 2. Is it? Yes, the value of b is 1 upon square root of 2, so its square would be 1 upon 2. So 2 into 25 is 50, 50 minus 1 is 49, so 49 under root is very nice, that is 7. So plus and minus 7 upon square root of 2, this is the value of y. So yes, this is the value of y. So x and y has now been found according to this value. Now they are plus and minus, and over here also we can do something nice to just factor it out. Let us do that. So 4 is there, so it can be written as 11 plus 2 times square root of 2 shifted inside, so 24. Yes, and factors of 24 are, it's like the surds. Yes, and it can be written as square root of 8 the whole square plus square root of 3 the whole square plus 2 times square root of 8 and square root of 3. So it would be square root of 8 plus square root of 3 the whole square. So it would be 2 times under root 2 plus under root 3 plus and minus. This is the value of y we get. Yes, plus and minus, this is the value of y. Yes, this is the value of y. And similarly if we will solve the surds for x, we will get the value of x is plus and minus 2 times square root of 2 minus square root of 3. Yes, this is the value of x and y from here, and the value of x and y from there is that x is equals to plus or minus 5 upon square root of 2, and y is equals to plus or minus 5, not 5, 7. Yes, it's 7 upon square root of 2. Now we have to check just which of these make the pair perfectly. So all of them will just solve the first equation very nicely because they are used just as a square over there, because x square and y square are used, so positive negative makes no changes. But in the second equation, x plus y the whole square is there. So keeping x and y over here, and we will compare this to get for which value x and y will set. Let me show that. So it's like a plus b over there. It's over there like this way. Let it be. Yes, it's like a plus b is equals to square root of 16 plus x plus y the whole square. Remember, I have considered a plus b in the beginning. So the value of a and b were having as a, the value of a was this thing, that is, for first I am solving, so 2 times square root of 2 plus square root of 12, and b was square root of 12 minus square root of 2. So when I will add that both, so what I will get is 2 times square root of 12. Yes, 2 times square root of 12. Now over here also, from over here I should get 2 times square root of 12. So 16 plus x plus y the whole square. So this should give me 2 times square root of 12, and this is nothing but square root of 48. So 16 plus x plus y the whole square should be equals to 48. So x plus y the whole square should be equals to 48 minus 16. That's equals to what? 48 minus 16 is equals to 32. So x plus y the whole square should be equals to 32. So we have the value of this, that is plus and minus this, or else plus and minus this. So let us take the positive value for both of them. So 2 times square root of 2 plus square root of 3 plus square root of 2 times square root of 2 minus square root of 3. So this and this cancels, so it forms 4 times square root of 2 and its square is 32. Yes, so this is satisfying. So let me write the final table x and y. Yes. Now first of all, both of them the positive value satisfied, that is 2 times square root of 2 plus minus square root of 3 and 2 times square root of 2 plus square root of 3. So this both pair satisfy. Now let us check one positive and the other negative. So first one I will keep the negative. Yes, negative, so negative 2 times square root of 2 negative square root of 3. The second one positive, so plus 2 times square root of 2 negative under root of 3. So this and this cancelled. Negative 2 times under root 3 and its square would be 2 square 4 3 12. That's not equals to 48. So this is not satisfied. And even I will take the vice versa of the sign, so they are not going to satisfy. But if I will keep both of them negative, so it will satisfy. Let me show you. Negative 2 times square root of 2 negative square root of 3 negative 2 times square root of 2 positive square root of 3. So this and this cancelled. So 2 times 4 times square root of 2 and its square root will be equals to what? 48. Yes, very nice. So this is going to be not 48, we want looking for 32. Wherever I have told 48 previously, it's wrong. It's 32. Yes, as we have derived from here, x plus y the whole square should be equals to 32. So the second pair we obtained is both of them as the negative value, that is 2 times square root of 2 plus square root of 3 and 2 times square root of 2 minus square root of 3. Yes, so for the first one, this both are there, that both of them is either negative or else both of them are either positive. Now let us check for this value, that is 5 upon under root 2 and 7 upon under root 2. Value of a plus b according to this case. So according to this case, the value of a we have that it's where it's gone. Yes, the value of a is 5 upon under root 2 and value of b is 1 upon under root 2. So according to this, if I will keep the value of a plus b over here, so 5 plus 1 will get me 6 upon under root 2 and that should be equals to under root 16 plus x plus y the whole square. Means what? 16 plus x plus y the whole square should be equals to 36 upon 2, that is equals to 18. That means x plus y the whole square should be equals to 2. Yes, according to this case, so x plus y should be equals to 2. So let me check over here which gives me that. So first of all, keeping both positive, so 5 upon square root of 2 plus 7 upon square root of 2. So it is 12 upon square root of 2 and its square would be 144 upon 2, that's equals to 72, which is not equals to 2. So keeping both of them positive does not satisfied. Now let me take one negative, one positive. So negative 5 upon square root of 2 positive 7 upon square root of 2. So it's negative 2 upon square root of 2 and its square would be 2. Yes, it's satisfied. Now let us skip the 7 one negative. So 5 upon square root of 2 minus 7 upon square root of 2. So it's over here it would be positive, so no problem, 2 we have got, but here it's negative 2 times square root of 2, so again we will get 2. So it's satisfied. And when we will keep both of them negative, so it will not satisfy. So here we obtain that sign should be vice versa. So 5 upon square root of 2 and negative positive 7 upon square root of 2, or else positive 5 upon square root of 2 or else negative 7 upon square root of 2. And these are the pairs of solution for x and y. And finally, we have found the value of x and y very normal, but here the things get complex is that according to the value of a and b, we have the equation that a plus b is equals to square root of 16 plus x plus y the whole square. So from here we have to find such an x and y, because negative positive were there, x and y over here, so it's satisfied. And in that also a plus b, according to two cases we have, this was the first case in which a and b has different value, and according to here a and b has different value, so addition of them get deferred, so a and b has been solved. And this is the full solution, which is not at all visible. So let me just show you the final solution over here. So this problem was very lengthy, many people have requested it, and I know everybody is going to ignore it. Yes, I know, but still for one viewer I have made it and he will get to know. So if you have any other method other than this, I think there's not, but if it exists which is smaller than this, you can do comment below, or else you can DM me on my Instagram, link is in the description. When someone gives a better solution other than this, and we can show it to our viewers, spreads the knowledge.